Section 9.1, we're going to look at graphing quadratic functions. A quadratic function is a function of the form ax squared plus bx plus c, where a cannot be the number 0. A can't be the number 0. If a is the number 0, then 0 times x squared, that's just going to be 0. That piece would go away. We would have y equals bx plus c. That would be a line. So we want something different. We want the x squared to be there, so we want a to not be 0. So these are called quadratic. Multiple times in my classes, I've had students ask me, why are they called quadratic? The reason is because of the square. If you look at a lot of old campuses would always have an academic quad in the middle. And the academic quad would always be in the shape of a square. So when people first started studying these quadratic functions, they called them quadratic because of the square in the academic quad. All right, that's not very important for you to know, but in case you were wondering. All right, the graph of a quadratic function is called a parabola. And there are two possibilities. The graphs will generally look like this, and they will be this way if a is a positive number, or they will be this way if a is a negative number. So we're going to have two possibilities. Either we have a big U, or we have a big upside down U. And I've heard my students call them a big smiley face or a big frowny face. If that helps, that's fine. On a parabola, there is one point that is more important than all the other points. For this parabola over here, it's the lowest point, and it's called the vertex. And for this parabola over here, it's the highest point, and it's also called the vertex. So the vertex is either the high point or the low point on the graph. It's the turning point. That's where the graph changes direction. And then you might notice, if my graph was more accurate, that if I draw this dotted vertical line that goes right through the vertex, what should happen is my parabola should be symmetric on either side of that line. What I mean by that is if I could cut my piece of paper in half right along that dotted line and fold it over, I should get exactly the same thing. And that dotted line that I just drew, that's called the axis of symmetry. Okay, for either one of those, that's called that axis of symmetry. All right, so here's what's going to happen in this section, primarily. I'm going to give you an equation, a quadratic equation. You're going to plug some numbers into the quadratic equation to get some dots on a graph, and then you're going to draw the graph. Now, what would be helpful would be if you could find the vertex. And the way they have you find the vertex in the book is to just plot a bunch of points and then recognize where it comes. I'm going to do a little better. I'm going to give you a formula. There's a formula for finding the vertex. Not covered in the book, but I think it's important to know. To find the vertex, if you have y equals ax squared plus bx plus c, a is not 0, the vertex occurs at x equals minus b divided by 2a. So that'll give you the x number. Once you know the x number, you can plug in to find the y number. All right, so let me give you some examples here. Basically what you're going to have in this section is you're going to have something like y equals x squared plus 4x. Okay, so the first thing I notice is this is a quadratic function. It's quadratic because it's got the x squared. The second thing I notice is that my a number right here, it isn't written, but it's really a 1. My a number is positive, so I know my parabola is going to have the big U shape. What I would do first, this is my personal opinion, I would find the vertex. Vertex happens at x equals negative b over 2a. Well, notice that a is the number 1 right here. A is always the thing that goes with the x squared. A equals 1. And b is always the number that goes with the x. So b is 4. So negative b over 2a, that's negative 4 over 2 times 1, that's 2. So that's negative 2. So x is negative 2. I would then plug my y number in. I would then find y by plugging in my x number, I mean. So y is going to be negative 2 squared plus 4 times negative 2. That's going to be 4 minus 8, that's negative 4. So right away, when I go to draw my graph, 1, 2, 3, 4, 1, 2, 3, 4. Again, we draw our axes and we scale them just as we always did when we were drawing linear functions too. Right away, I know I have the point negative 2, 4, negative 2, negative 4. That's my vertex. And I know my parabola is going to open upward. All right, so all I do now, build myself a table, plug in some numbers. So my general rule is plug in a couple negative numbers, plug in a couple positive numbers, plug in 0. So I'm going to plug in negative 3, negative 1. I skipped to negative 2 because I already plugged in negative 2. 0, 1, 2, 3. So I'll plug in all those numbers and I'll see what happens. Well, let's see. When I plug in negative 3, I get negative 3 squared plus 4 times negative 3. That's 9 minus 12, which is negative 3. So I have the point negative 3, negative 3. Now, here's a little check for you, of course. If I were to plug in negative 3 and get an answer of like negative 8, I should recognize I made a mistake because this vertex right here, this has to be my lowest point because this parabola is opening up. All right, let's see. When I plug in negative 1, I get negative 1 squared plus 4 times negative 1. That's 1 minus 4. That's also negative 3. That should happen too. Here's another little built-in check. If I go one step to the left of my vertex and one step to the right of my vertex, my y values should be exactly the same. That's the axis of symmetry property. All right, so now I'm going to plug in 0. 0 is easy. If I plug in 0, I get 0 squared plus 0, that's 0. Plug in 1. If I plug in 1, I get 1 plus 4, that's 5. 1 comma 5. And you know what? I'm going to change my mind here because I'm getting up off my scale. I think what I'm going to do instead of plugging in 2 and 3, I think I'll plug in a couple more negative numbers. I think I'll plug in negative 4 and negative 5. Now, once again, notice when I plugged in 0, I got 0. And 0 was 2 steps away from my vertex. So when I plug in negative 4, I'm 2 steps to the left of my vertex. I should get 0. That's my axis of symmetry property. Let's see if that works. That would be negative 4 squared minus 4 times negative 4. I'm sorry, negative 4 squared plus 4 times negative 4. That's 16 minus 16, which is indeed 0. And again, when I plug in negative 5, I know I should get an answer of 5. It should be at the same height as this dot over here. Let's check to make sure that works. Negative 5 squared plus 4 times negative 5, that's 25 minus 20, which is 5. All right, so there's my picture. Oop. Oh boy, that wasn't very good. I missed. Now that's one of the weaknesses of using this pen that I'm using. I can't erase, so hopefully when you draw your graphs, you'll draw them a little better than I just drew mine. All right, let's do one more. Let's do one where the parabola opens downward. How about y equals negative 2x squared plus 8x minus 3. Okay, once again, I look and I notice that my parabola is going to open down. I notice it's a parabola because I got the square right there. And I notice it's going to open down because that number is negative. Okay, so once again, I would begin by finding my vertex. X equals negative b over 2a. In this case, here's my b number. B is the number 8. Here's my a number, negative 2. So I'm going to have negative b, that's negative 8, divided by 2a, that's negative 2 times 2, that's negative 4. Negative 8 over negative 4 is 2. Now I find my y number, so that's going to be negative 2 times 4 plus 8 times 2 minus 3. So that's negative 8 plus 16 minus 3. That's 8 minus 3, that's 5. So my vertex is the point 2 comma 5, and this time I know that my vertex is a high point because this parabola opens downward. Once again, I draw my axes, scale my axes appropriately, and I've got 2 comma 5. Alright, so once again I'm going to build a table. And I think what I would do is I would pick a couple numbers bigger than 2, like 3 and 4, and a couple numbers smaller than 2, like 0 and 1. And again, I should get a symmetry thing going on here. Alright, so let's see, if I plug in 3, I've got negative 2 times 9 plus 8 times 3 minus 3. Let's see, that's negative 18 plus 24 minus 3. That's going to be negative 18 plus 24 is 6. 6 minus 3 is 3. So I got 3, 3. Plug in 4, I'm going to have negative 2 times 16 plus 8 times 4 minus 3. Negative 2 times 16 is negative 32. 8 times 4 is 32. Minus 3, that's minus 3. That one turned out pretty easy. 4, negative 3. Alright, now if I've done stuff right, when I plug in 0, I should get an answer that I've gotten before, and when I plug in 1, I should get an answer that I've gotten before. That's our symmetry property. Well, plugging in 0, that's my favorite number. Plugging in 0 is easy. I get 0 plus 0 minus 3, that's minus 3. So 0 minus 3, that's the same y value I got before. That's good. So if I plug in 1, I'm expecting I will get an answer of 3. Let's make sure that happens. Plug in 1, I have negative 2 plus 8 minus 3. That's 6 minus 3, that is 3. So it works out. Alright, so let's see if I can connect the dots a little better this time. There we go, there's our parabola. Alright, so that's what you're going to do in this section. Basically, you want to find the vertex, pick a couple numbers bigger than your x value of the vertex, pick a couple numbers smaller than your x value, plot it all out, draw yourself a pretty picture.